Greetings to CMP 1002 Object-Oriented Programming with C++ series. In this video, we will look at classes and objects in C++ language. Specifically, we will talk about accessor categories, constructors, the static keyword, pointers to classes, and finally, the this keyword. As we have described in the previous video series, the CMP 1001 video series, there are some variable types in the C++, which are like the integer, the double, the char that we have used a lot to keep single points of data. C++ calls them primitive data types, and there are basically 5 data type groups in that sense. The integer types, which are like the int, short, long, and floating point types, which are basically the float, double, and the long double, the character types, the boolean, and the void. But aside from these primitive data types, we also have ability to make custom data types, and these are called the classes. These classes basically constitute the building blocks of object-oriented programming in the C++ language. Normally, when you declare a variable from a variable type, that thing is called a variable. However, when you declare a variable of a given class type, that variable is also going to be called an object. You can still call it a variable, obviously speaking, but it is also more commonly called an object. So if you look at this declaration example, this std::if stream input file, the std::if stream is actually the name of the class. You can consider it like the type. Whereas the input file is the name of the variable, or in the sense, the name of the object. And this object is an object derived from the class std::if stream, or you can call it just ifstream. So whenever you make an object out of a class, it is called that that object is derived from that class. At this point, you might be thinking like, cool, so there are a lot of these new variable types, so let me learn all of these things so that I can use them whenever I need. Well, there are actually a lot of classes. A lot of classes that comes with the standard libraries of C++, and if you are looking for a particular library that is designed for different uses, such as machine learning, image processing, computer network design, things like that, you will see other bunches of classes specially designed for those kind of needs. So there are basically innumerable amount of classes, so nobody even wants to categorize them, let alone memorize them. Instead, programmers generally use a more practical approach when looking at classes. So you learn the classical classes, the one that have been used over and over again, like the ones you're seeing here, the ifstream, the oifstream, things like that. And then when you have a specific need, you just check around all possible classes in the standard libraries and other libraries that are available over the internet, and then you just learn them, use them. In addition to these already available classes, C++ also allows us to make our own classes. The ability to make custom classes as we fit, as it suits to our needs in the application that we are trying to build, is gonna be the critical component of this whole object-oriented programming concept. Because if you remember our discussion in the first week, object-oriented programming is basically data before action kind of a philosophy. So you have to first think about what are the data objects, and then you have to think about how do these objects interact with each other. So let's now look at how can we make a new class in C++ language. It is a pretty simple syntax actually. So you just start with this writing down the keyword class followed by the name of the class, which follows the classical variable naming rule. Then you just write down whatever fields and whatever functions that you want to put inside that class, defining all the data, all the multiples of data that you want to keep under this class, as well as all the functionalities that you want this class to have within this curly bracket couple, and then you finally write down a semicolon to just finish it up. A very simple example is going to be something like this. Let's say I want to have a class called a naval ship, which is, as the name suggests, going to be representing a naval ship. So let's say our class naval ship will be composed of 3 fields. One string representing the model of the ship, one integer representing the height of the ship, and the number of crews represented by an integer called the crew. So this part is going to be representing the definition of the class. Then in the main, I can just make as many objects out of this class as I can make variables out of integers, doubles, chars, all these primitive data types. So I'd simply write down the name of the class followed by the name of the object, again, which is going to be following the classical variable naming methodology. Nothing so complicated, and as I can have as many objects as I want, and I can just go on and on like that. So these classes, as I mentioned, is going to be composed of basically two groups of items: fields and the functions. The fields can be composed of primitive data types like the integers, doubles, chars, things like that, or objects of other classes. That's also acceptable, and you will soon realize that this chain will go on and on as many levels as you need. The functions, on the other hand, again, you can just put down as many functions as you see fit to this particular class definition. Unlike these field variables, these function codes will be shared among different objects of the same class, because the fields are actually going to be different. What do I mean by that? So I have an object A of class X and I have an object B of class X. Imagine that these are two boxes, and each one of these objects have their own field 1s, have their own field 2s, have their own field 3s, and they can have just different values at a given time. However, the functions are going to be the same functions, and they're going to be shared among all objects of the same class. At this point, I would like to also emphasize there are basically two types of classes, depending on where the class code is going to be. The first one is going to be what is called a local class, and the second one is going to be called the global class. If you just put all of your class definitions within a single CPP file, for example, let's go with the classical main.cpp example, and if I just have my declaration of classes within this main CPP, that is gonna be the local class approach. This is easier in some sense, but it is a bit, if you go to a more professional way of writing down, that's not a very, very nice idea. Instead, what you want to do ideally is gonna be writing down each class to its own file. So if you have class 1, then you want to write it down in what is called the class 1.cpp. And if you have a class 2, you want to write it down in class 2.cpp, and on like that. Generally, people also added a header file. So for each class, there's going to be the .cpp file and .h file. So let's go ahead with an example here. So I would like to define a class named point3d, which is going to hold the information of a point in a three-dimensional space with three fields as x, y, and z, representing the x, y, and z coordinates of the point. And well, these things can be an integer, but I think using a double variable for these fields are going to be a better fit, because these coordinates can be a real number. So I just go over the main and then start typing by saying class point3d. Open the curly bracket, close down the curly bracket. And then I just start writing down the type of the fields, well, double. And then I can call them chord x, because I just feel like this is more representative. Similarly, chord y, and similarly, chord z. So this is going to be a super simple class representing a point 3D item, a point in a three-dimensional space. And I can just, as I mentioned, make an object out of this class by saying, for example, p1. And I can make other objects out of this class, p2, p3, whatever I want. But when I want to access these things, let me try to do that. And let me say like p1 dot chord x equals 5. Well, you might be by normally expecting that I should be able to put some values inside these doubles, because currently our class point3d is basically package of a couple of doubles, 3 double items. What does he say when I try to do something like this? He says chord x is a private member of 3d. Okay, so there is actually something called a private, being a private member of this class. So at that point, I have to go back and then talk about something called an access modifier. Each field and function of a class has an access modifier in C++. These are public, private, and protected. But for the time being, we're going to be sticking with the public and private, because for protected, we'll be covering in upcoming videos. Whenever you call any field or function as a public thing, it means that any object, not just objects of this type, any object can access these fields or functions. But if you, in the reverse, if you just say like this field or function is a private field or function, it means that only the functions of this particular class can access these fields or functions. Nothing else can access or use these fields or functions. And if we do not explicitly define an access modifier to any field or function, in C++, the default value, the default access modifier value is private. So since in this code I did not say anything specifically in regard to the access modifiers, all these three items have been defined as private. How am I going to make them public? I simply go and then type public colon. So unless I switch to some other access modifier like private or protected, all of the following items will be having the same access modifier. So right now, all three items have the public access modifier. Hence, the main, which is a function outside of this class definition, is able to read and write to these fields. If I just change it to private, now this p1.coredex, I am unable to read, unable to write to these fields because they are now private. They are private properties of the class. So you might be asking the question like, why do we need these access modifiers? Basically, the main idea here is to control and limit who can access which variable, which field, and which function. It's a bit of an organizational concept, and it's a bit of a privacy concept. In a more generic terminology, in a more generic object-oriented terminology, it's called information hiding. We may not want everybody able to change or even read all the fields of our classes, because that can be very problematic when you are dealing with very, very big pieces of code having composed of like hundreds of classes. Who is able to access what is gonna be a very important design decision when you are designing these classes. So let's go over this example. Modify the point3d so that the fields of the class point3d are private fields. Okay, I guess we already did that. Yep. Also, write a public function for the point3d class. Double calculate distance point3dp. So the name of the function is going to be calculate distance. It's going to return a double value, and it is a single parameter called p, whose type is point3d. So this function is going to calculate and return the distance between this point3d object and the given second point3d object named p. So it's going to be a little bit of a geometrical calculation. Okay, so I'm going down here, and first of all, I am just going to write down public colon to represent that this function is going to be a public function. Then I'm going to say double calculate distance point3d p. Okay, so at this point, I have to just calculate the distance between these 2 point objects, these 2 point3d objects. So how can I do that? I am just gonna simply take the subtraction of the coordex of this object and the coordex value of the p, the second point, and then take the square of it. I do the same thing for the y coordinates. I do the same thing with the z coordinates. Sum them up and take the square root. Okay, so I'm gonna start by saying sqrt. I have an sqrt in the CMAT library. I will be adding the CMAT on the top shortly. Then I'm gonna say pow coordx minus p dot coordx, comma 2 CMAT. Okay, now I am just gonna get the difference between the x positions and then take the square of this thing, plus same logic, pow coord y minus p dot coord y, comma 2.0, and then same thing with the z coordinates, coord z minus p dot coord z, comma 2. Take the square root. Okay, I did that. and I can simply return this value back to whoever is calling this function. Okay, so simple geometry information. So now I am gonna be able to say p1 dot calculate distance p2, and I can simply put it inside an std code, and then I can just have a bit of an actual output here. But if I run this code, now I actually did a bit of a mistake here. I did a bit of a strange thing, therefore the result is gonna be a weird number. The thing is, I did not initialize neither the p1 nor the p2. So their codex values is completely random. Well, depending on the compiler that you are using, but in many occasions it's gonna be a random number. But I cannot set the values of chord x's, chord y's, and chord z's of these guys because they are private fields. So how am I gonna initialize these fields in these objects? How am I gonna do that? So to this end, we have a special function called a constructor. A constructor does not have a return type, and the name should always be the name of the class. So it has a bit of a special rules. So you never type down return type because there's no such thing, and the name is gonna be the name of the class. So in our example, it's gonna be point3d. But it can take as many parameters as we want. These functions, this constructor function, is gonna be the main way of initializing the object. So this is basically where you are saying, make an object, here is your x coordinate, here is your y coordinate, here is your z coordinate. So take them and put them into their respective places. For very obvious reasons, these functions, the constructors, is gonna be public thing, otherwise it doesn't make a lot of sense. Well, there are some use cases where some of the constructors are defined as private, but well, for the time being, let's just keep them as public. So here the example continues by saying that write a constructor to the point3d class that takes 3 double values as parameters and put these values into the x, y, and z coordinate fields of the object. So I'm gonna declare another function now. And this is gonna be the constructor, so no return type. The syntax is a little bit different. And the name of the function is gonna be the name of the class, point3d. I'm gonna take 3 fields. Let us call them double x, double y, and double z. Open up the function, close down the function, and then I'm just gonna say chord x equals, well, x, chord y equals y, chord z equals z. Okay, now I have a constructor. You don't also call this function like a regular function call. Whenever you make an object out of this class, that constructor function is automatically called. So when I'm making an object by saying point3d p1, I am actually calling this constructor function. So as you can see here, this constructor function is expecting me to give him 3 double values. So now this this piece of line is no longer a valid piece of code. When I go over here, he's gonna say something like no matching constructor for initialization of point3d. So he's basically saying that the constructor of this class is expecting 3 double values, but here you are not providing any. So what I should be saying something like this. Okay, now this is an actually valid object declaration. So cline is helping me by writing down x column 5, y column 6, and z column 7. So I'm now understanding that the first value is going to be the value of x, second value is going to be the value of y, and the third value is going to be the value of z. Therefore, first value is going to be chord x's value, second value chord y's value, third value chord z's value, because of how we write down the constructor. So let me continue in this fashion, and then I'm just gonna put a very close by point to point P2. Now when I run this code, you will see a more logical, understandable, and readable result of 4, because now the x coordinates are the same, y coordinates are the same, only difference is in the z coordinates. So 11 minus 7, 4, 4 multiplied by 4, 16, 16 plus 0 plus 0, well, 16. Take the square root of 16, and then you still have the 4. So now we have a more well designed class with a constructor, which is gonna be managing how you initialize any object out of this class. And now we have another function, this calculate distance, which does something over the various fields of this class. We have a couple of different syntax when we are declaring constructors. The one you see at the top is what you can be expecting from a regular function usage. I can simply say like x equals y, y equals b, and z equals c, where the field names are x, y, and z. But in the object-oriented programming syntax of C++ language, you can also have an alternative syntax, as you see at the bottom here. So in it, next to the line, next to the first line that you declare the function, you just say after a colon xa, comma yb, comma zc, having the same functionality. When we are dealing with just primitive data types, these two things are more or less equivalent. But when we are dealing with some member fields which are not primitives, which we'll be seeing in the upcoming parts, then the second syntax is gonna be much more efficient and will have some advantages over the first notation. Therefore, in many occasions, I would suggest you to use the second one, and that's gonna be the one that I will be using in the rest of this series. Normally, all classes have a default constructor, which is a constructor that does not take any parameters at all. The moment we add a non-default constructor, like the one that we added to the point3d class, having a couple of double values and then just puts them into their correct places. Whenever we add such a thing, this hidden default constructor simply goes away. And if we still want to have such a constructor that doesn't take any parameters at all, now we have to explicitly define a default constructor. Although not necessary, it is generally best practice to add an explicit default constructor to all classes that you make. In the point3d class that we have declared, all the fields are actually doubles, simple primitives. But we mentioned that a class can have fields of other classes, it can have other objects. So let's look at it with an example. So here we would like to add a second class. This class is going to be called line segment 3D. And this one is going to hold the information of a line segment in a three-dimensional space. Obviously, a line segment is represented by two point3d objects, and therefore there's going to be two point3d fields. The first one is called start point, and the second one is called the end point, representing the start and end points of this line segment. Also, we would like to have a constructor to this class, which takes two point3d objects and initializes line segment 3D object. And finally, we would like to add a function to this class called calculate length, which is going to calculate the length of the line segment. But since we have the calculate distance function of a point3d class, and a line segment is defined over two point3d objects, and we can simply call the calculate distance of one of them and give the other one as a parameter, and then voila, we can actually calculate the length of this line segment. Here, after the class definition of the point3d, I'm just continuing by saying class line segment 3D. And again, with the classical information hiding system, I would like to have two private point3d objects, point3d, start point, point3d, end point. The constructor is obviously, as I mentioned, is going to be a public function, and apparently it's going to be having two point3d objects. Let's call it p1 and p2. And I'm going to be using the other notation when I'm declaring the constructor, not the one that I have used in the previous point3d class. So I'm going to say start point within parentheses p1 and end point within parentheses p2. Open up curly bracket and close it down. So basically this is going to take the values and then put it inside the start point and the end point. Afterwards, we will have the calculate length function. Its return type should most likely be a double calculate length. It's not going to take any parameters because it already has all the parameters it needs, and I'm going to say something like start point dot calculate distance end point. Let's go to the main and then make an object out of line segment 3D. Let's call it L1 and then I'm just gonna give it to P1 and P2 as parameters. Then instead of saying P1.calculateDistance P2, I am gonna say L1.calculateLength. And since these are the same points that we have declared previously, the length is gonna be again 4. So as you can see here, we don't have any specific syntax regarding using an object as a field compared to using a regular primitive as a field. And what is very flexible and very powerful thing is I can just use the calculateDistance function of the point3D class inside the calculateLength function inside the class line segment 3D. Similar to, I can use the same function from the main, because from the point3D class's point of view, calculateLength function is a function outside the class. Similarly, the main is also a function that is outside of the point3D class. So for the point3D class, they are functions of different classes. It doesn't really matter that much. So when I was talking about the default constructor, you might have a bit of a question in your minds. You were saying it's the best practice to have a default constructor, but we already have a non-default constructor. How can I have more than one constructor for a given class? Actually, a class can have more than one constructor. This is basically called constructor overloading. And how can you do that is actually all of these constructors should have different parameters. So in the default constructor discussion we have, the point3D class already has a constructor having 3 double parameters. So I can have another constructor which doesn't have 3 double values. This is perfectly fine. You can actually have as many constructors as you want, but the critical thing is the parameter set of every single one of them should be different. So let's go with this example. So he says, write a second constructor to the line segment 3D class. This one, instead of taking 2 point3D objects, it should take 6 double values as parameters and just initializes the class. It might be a little bit more trickier, and you can consider that this is a bit of a not a super useful thing, but let's just do it for the sake of fun. So I'm gonna say double P1x, double P1y, and double P1z. Similarly, double P2x, double P2y, and double P2z. Then I'm gonna continue by saying start point, but this time I don't have P1, I don't have P2, but I have P1x, P1y, P1z. So I'm gonna say P1x, P1y, P1z. So here I am actually calling the regular constructor of the start point, because the constructor of the start point, the constructor of the point3D class is the one that takes 3 parameters, 3 double values. So I'm calling that constructor of the point3D class here. So following the same notation, I'm gonna say endpoint P2x, P2y, and P2z. Open up the curly bracket and then close down the curly bracket. So now I can go to the main, and instead of following line 41 and just calling line segment 3D L1 with 2 point objects, I can have line segment 3D, let's call it L2, something like 7, 8, 10. This is gonna be the first point, the start point of this L2, and let's call it 10, 8, and 10. So here only the x coordinates are different. So if I just calculate the length of L2, it's gonna just giving me, I think, 3. Let's check it out. So this is an alternative way now, because now line segment 3D class has 2 constructors, one of which is taking 2 point3D objects as parameters, one of which taking 6 double values as parameters. So I can just go as many times as I want based on, and I can just use as many different parameters as I want. And the classical default constructor should be something like this: line segment 3D, and then it's gonna maybe do nothing. But this is not a very useful one, right? So I can say something like this here. Instead, start point 0, 0, 0, end point 0, 0, 0, something like this, for example. And I can just do things like just putting a default constructor to the point3D object, and then I can go on and on like that. So it completely depends on what I'm trying to achieve here. So let's have another example where I will be having a third class. Using the point3D class that we have defined, define another class called sphere, which has two fields: point3D center, double radius. Well, this is a sphere, so it has a center as a center coordinate, and it has a double value, which is going to be representing the radius of the sphere. I would like to have a couple of constructors for the sphere. A default constructor that sets its center value to 0, 0, 0 and radius to simply 0. And a more logical constructor that takes a single point3D object and a double value and initializes the object, as you might imagine. Lastly, I would like to have two functions named calculate area and calculate volume, which calculates the area and the volume of the sphere using the formulations below you see. 4 times pi times r squared, 4 divided by 3 times pi times r to the cube. So again, I'm just going down here, and then I'm just gonna have class sphere private point 3D, let's call it center perhaps, and then have something like double radius public, because as you might remember, the constructors are supposed to be public things. Sphere, the empty constructor, which is gonna not take any parameters at all, so it's gonna just say center 0, 0, 0, and then radius is gonna be simply 0, or if you want to be more precise, I can just put 0.0 to every single one of those things, because they are not integers, they are all doubles. So more useful constructor for the sphere, it is gonna take a point3D object, let us call it P, and then a double value, let me call it R. And then I'm gonna again say something like center P and then radius R. The two functions that I also want to add here, the calculate area and the calculate volume. So again, the return types are supposed to be something like double, I guess, because, well, there's gonna be a multiplication with radius, and radius is already at double, right? Double calculate area. Again, it's not gonna take any parameters at all, so it's gonna be 4 times, I can say something like, I guess, 3.14 times radius. And similarly, I will be having calculate volume, because this is a sphere, return. This is a bit tricky. I don't want to say 4.3 because then it's going to be making an integer division. So instead I'm going to say 4.0 divided by 3 multiplied by 3.14 again, and then multiplied by radius times radius times radius. Or if you will, you can use the power function to have the same effect. And then I just go here and then sphere. Let's go at S1, and then it's gonna take the P1 as the first parameter, and then let's call it 5 for the radius. And I'm just gonna call S1.calculate area and S1.calculate volume. In order to avoid some clutter, I'm gonna comment this part out and then run the code. So radius is 5, 5 times 5, 25, 25 times 400, 100 times 3.14 is gonna give me 314 as the area, and you can calculate the volume similarly. So this is a bit of another example using the same concept. We have mentioned that there can be two types of classes based on where the class code are located. either a local class or a global class. And the classes that we have written so far is actually local classes, because all of the code are actually stored inside the main.cpp, inside the same file, although we have declared 3 separate classes. So in a global class concept, each one of these classes generally have 1 or 2 separate files. One of them is, as you can see on the right hand side, a CPP file, and the other one is going to be a header file represented by this .h. There are a couple of variations here. I mean, you don't technically have to have a .cpp and .h coupled. You can have only a CPP, or actually you can also have .h. But the general consensus, let's say, is the best practice is having 2 of these files. One header file, the one on the left, and a source file, the one on the right hand side. So why do we have such a difference, such 2 files instead of a single file? In the header file, we're going to be declaring the class with its fields, with its functions. But the key difference is going to be here is the fact that we are not going to be declaring how the function will actually work. We will not have the implementation of the functions. So the header file is going to basically like a blueprint of the class, like a design specification documentation. Whereas the CPP file is going to be the actual implementation of every single function we have declared in the header file. So these 2 things will just gonna be like the flip side of a coin. So both of them together, they represent an actual class. Why do we have such a division of responsibilities? Because generally when you have a very big code base, you may want to share the .h file, whereas the CPP file are going to be encrypted. So how your functions are being implemented, you may want to keep them as a secret. However, the header file, you can just open it up and then you can just let it to be a public information. It's not that critical of an information. So when you have this .h, .cpp kind of a global class concept, the syntax changes only a tiny little bit. So on the .h file, as you can see, the only difference is in the function, when the double calculate length, I did not write down how the function works. I did not write down return blah blah something. Instead, I just put down a semicolon at the end. Whereas in the .cpp file, the actual source file, I just write down all the functions, but when I'm writing down the functions, I just start by saying that line segment 3D colon name of the function. So I'm simply saying that this function is line segment 3D classes function. Which function? Calculate length function. From which class? Line segment 3D. In order to these 2 files be able to understand each other, the critical thing is the CPP file should be able to understand the H file. So how do I do that? I just add this include line segment 3d.h at the start so that the CPP is now able to access everything you have written inside the header file. In a more professional fashion, a global class is actually a better fit. However, throughout this series, for the sake of practicality, I'm going to be using a local classes. Fields of a class can also be defined with the attribute static when they are declared. If you declare a particular field as static, unlike the regular fields, these ones will be shared among all instances of the class. In other words, a static field is going to be the same variable for all objects that have been derived from that class. So this is going to be not a field of an object, it is going to be a field of the class. So if one of the objects change the value of this particular field, its value will be changed through all other objects derived from this class, because it is not part of an individual object. It is going to be part of the whole class. So this is a bit of a different mindset, let's call it. So normally we say that a field is a part of the object. It is not part of the class. But there are occasions where it makes more sense that a particular field is going to be part of the class, the overall class, not an individual object. In those kind of scenarios, this static keyword is of paramount importance. A super simple example of such a use is when you want to have some information like how many objects that have been initialized out of this class. For example, in this point3d class, we may want to add a static field named total point count, and this field will represent the total number of point3d objects that has been instantiated so far. So if there is a single point3d object has been instantiated, then the value of this thing is going to be 1. But if there are 5, the value of this thing is going to be 5. From which object you access to this thing, since it's going to be a shared variable, a static variable, it's going to yield the same result. So we would like to declare the field within the class definition, but there's going to be this interesting thing here. We would like to initialize the static field not inside the class definition, because we are going to be unable to do that. We're going to be initializing the static field outside of the class definition, because as I mentioned, this field is now going to belong to the class, not in a particular object of the class. So we cannot, similar to the regular fields, we cannot initialize them inside the constructor. It doesn't make any sense. And finally, I would like to declare and implement a very simple function named getTotalPointCount that does not get any parameters and return the value of total point count of the point3d class. So first of all, I go above here to the point3d class again, and within the private fields, I'm gonna say static int total point3d count. This is now a static field because of this static keyword. But as you know, every single field, every single variable needs an initial value. Otherwise, the initial value is going to be a random number. So how can we initialize it? Because it doesn't make any sense to try to initialize it within the constructor. So we have to initialize it outside of the class, because it's going to be now part of the class, right? So I'm going to say int point3d total point3d count equals 0. So here, this is gonna be the initialization of this static field in this particular project. So you can see these arrows referring to the definition declaration of this particular field now. If I click here, I am just gonna jump up here where this field is being declared. But when I click here again, the initial value is set here. So again, my IDE is helping me to find the definition declaration of the same field. So I would like to have one more function here. I would like to have int get total point count, let's call it. And then I'm just gonna say return total point3d count. But we mentioned that what is the purpose of this total point3d count? How many objects have been initialized so far? So who is governing if an object has been initialized out of this class? The constructor is governing this thing, because I mentioned that whenever I make an object out of this class right now, the constructor is automatically called. So at the end of the constructor, what I would like to do is total point3d count plus plus. So I'm just basically saying that whenever the constructor has been called, increase this value by 1. So when the first object has been initialized out of this class, then the total point3d count will be 1. When the second object out of this class has been initialized, 2 and 3 and then 4 and so on like that. Okay, so how can we see this thing in action? So let's try to have, after every single one of these lines, let's try to print out the total, the get total point count of P1. So I'm just going to say std quote P1 dot get total point count, stdnl. I'm just going to do the same thing here, here, and finally after the declaration of the sphere. Again, in order to avoid any clutter, I'm commenting out the calculate area and the calculate volume functions and their codes. Okay, so we have this 12244. Let's look it up. Here at line 67, we are initializing the first point 3D object. Therefore, the getTotalPointCount yields a value of 1, which makes a lot of sense because, we have made a single object. In line 69, we are making a second object, a second point 3D object. After which, when I call this getTotalPointCount function, I am getting the value of 2. So since this total point 3D count is a static field, actually it doesn't matter if I call P1's getTotalPointCount or P2's getTotalPointCount. So if I simply call this one and then run it again, you will see that again the same result. The second one will have the value of 2. So it really doesn't matter because it's actually referring to the same exact variable. After the line segment 3D L1, P1, P2, you see that the getTotalPointCount did not change. Well, this is because we just passed the P1, P2 to the L1. So now P1 and P2 is being referred to also by the L1. No new point 3D objects has been initialized, actually. It has been also just referenced one more time. However, if I see the output of line 75, it says 4. So apparently, between line 73 and line 75, 2 more point 3D objects has been initialized. Where, you might ask? Because in this line segment 3D constructor, the other constructor, the one that takes 6 double values instead of 2 point 3D objects, this constructor actually makes 2 more point 3D objects. Therefore, the total point count has been increased to 4. In line 77, it is very similar to line 72, so only the P1 object has been referenced again. No new points have been made. Therefore, the total point count value did not change at all. Therefore, the result is, as you can see, simply 4. So the static is a little bit of a strange thing, and this is a good use case where occasionally you may want to get how many objects that has been made out of this particular class. But it is not limited to, static is not limited to such use cases. You will soon realize that there are other use cases where static attribute is quite useful. In addition to declaring a particular variable as static, we can also declare a function to be a static function. That's also possible. This means that these functions can be accessed without declaring any object from the class. So in order to use these functions, we don't need to make an object out of this particular class now. The CMAT SQRT, CMAT POW, those guys, or STD code, STD CIN, if you think about it, we are not declaring any items out of STD. We are not declaring any objects out of CMath, but we are directly referring to a particular function of a class. Well, because those guys are actually static functions. We don't need to declare an object out of these classes. So when you want to have a function which should work and without declaration of any particular object out of this class, static is a good way to go. So an example is going to be like changing the getTotalPointCount function to static function and use it in the main. So let's go again, and here I'm just going to say, instead of int getTotalPointCount, I'm just going to say static int getTotalPointCount. From this perspective, nothing has changed. If I go down here, my IDE is gonna say like, this doesn't make a lot of sense. Like P1.getTotalPointCount doesn't make a lot of sense now. Well, because now the function also belongs to the class. It is no longer belonging to that particular object of the class. So instead of saying P1.getTotalPointCount, I'm just gonna say point3d : getTotalPointCount. Now it makes more sense because it is a part of the class. It's not part of the objects, any individual objects anymore. So if I run it, you will see that we will have the same results. 1, 2, 2, 4, 4. And now it makes more sense. There's a bit of an interesting thing here that you have to be careful about. Since static functions are parts of the class, not part of a particular object of the class, a static function can only access static fields of the class. So, in reverse, a static function cannot access non-static fields of the same class. So this is something of importance because, as I mentioned, static functions is part of the class, and static variables is also, static fields is also part of the class. So they can refer to each other. But a static function trying to reach a non-static field, then which one of these fields is he supposed to access? Because every single object will have its own version of every single non-static field of that class. So it doesn't make any sense. But non-static functions, as you can see, non-static functions can still access static variables, static fields of the classes. Similar to the primitive data types, in C++, we can also declare pointers to classes. You might be asking, why do we need to declare pointers to classes? There are multiples of use cases for declaring pointers to classes, and one very classical usage is to just declare a class in the heap compared to declaring one object in the stack. We're gonna be covering the stack and heap concept and what do they mean and what is the benefit of declaring an object in the heap in the upcoming parts of this video series. To initialize objects via pointers, we have a couple of methods available for us. And one common method is the new keyword. So the code piece on the left hand side of this slide, I'm just declaring two objects like the P and the Q as normal. And since P and Q are actually objects, I can just use the dot notation to access any public field, or I can use it to access any public function of the point3d class by saying simply p.calculateDistance Q, for example. If I say point3d star P, now P is not an object. P is a pointer for a point3d object. So I can only say things like P equals new point3d 6, 12, 10. So in this sense, I'm making a point3d object with this new keyword, and I'm getting the address of this newly created point3d object, and then putting the address of that object inside P. So again, P is not an object anymore. P is a pointer that keeps the address of an point3d object. Because of this distinction, I cannot now use P dot notation because P is not an object, but P is an address. So normally I should be saying like star P within parentheses and then dot calculate distance using the classical notation. But C++ allows us a second notation, which is more commonly used when you have, well, pointers to classes. And that is the dash arrow notation, as you can see here. So now I am going to be calling the calculate distance function of the point3d, of the object whose address is kept in P by saying P dash arrow calculate distance. And since that function is taking an object, not an address of an object, I can no longer send him the Q. I have to send the actual object, which can only be accessed by the dereferencing operator. Hence you see like calculate distance within parentheses star Q. Similar to the dynamic memory allocation concept that we have talked about in the CMP 1001 series, the malloc, realloc, and calloc, we said that after declaring a dynamic memory allocation, you have to call the function free to, well, free the memory space so for other uses. Similar to that, after finishing using an object declared via pointers, we have to free it. But this free keyword is not going to be useful for us, but instead we use the delete keyword in this context. So after the declaration, as we had done in the previous slide, at the end of my program, when I no longer need to access these objects, they are completely useless, I have to say delete P and delete Q. So in this sense, I'm just saying to the operating system that these objects are no longer going to be used, so you can free them, you can just use these memory spaces for whatever purposes that you would like. One last item about in this part is going to be the this keyword. This is basically like a pointer to the object itself. Okay, it might sound something like a strange thing to you. On some occasions, you need to access the address of the object within the object, within the class scope. And in those kind of scenarios, C++ has this keyword. You can imagine this keyword as like a hidden parameter in every single non-static function of a class. So it's already there. This is like a pointer to the class. So if I'm talking about a point3d, actually the type of this keyword is point3d star, point3d pointer. And the value of this particular pointer is automatically the address of the object in question. So as I mentioned, this is a pointer to the object itself. So if I want to say something like I want to access the chord x or the x of that particular object, I can say, as you know, like x. Well, I can also say this dash arrow x. As you can see, I'm using now the pointer notation, the dash arrow. Why? Because the value that has been kept inside this parameter is actually the address of the object. So I can no longer use the dot notation. I cannot say this dot x. I can only say this dash arrow x. When I say that, it means I am referring to this particular object's x. So when you talk about this keyword, generally the terminology gets very confusing because of the name of the this being this. But well, this is not accessible within the static functions of the class. As I mentioned, they are only accessible within the non-static functions of the class. You might be thinking like, why do we need this? Because you can get around this accessing your local fields by just, accessing the local name fields by their names. Another common use for this is utilizing chain function calls. So what is that, you might say? So you might have heard some special functions or, well, specially named functions like the set function or the get functions. These are generally very classical but very simple functions that just allows you to change, or, well, as name suggests, sets the value of any particular field of the class. So in our case, we have chord x, chord y, and chord z, and they are private values, but we can get around this information hiding concept. We can get around by this access category by just writing down a function called setX, which we're going to be giving a double value, and that function's job is only going to be putting that value inside the chord x. There are some occasions which these kind of set functions is useful. So why am I saying this? Because on many classes you can just write down some chain function calls, as you can see here, like p.setx12.setY15. Okay, the first part is very straightforward. I'm just calling the setX function of the object p. That's good. But which object's set y am I calling? You might be asking, because that p.setX's return type should be a point3d object in order to make this line a valid piece of line. So this chain function call concept allows me, the setX function, to return the object itself, so that you can just write it down like this, like .setX, .setY, .setZ, and go on and on like that. So the example says we would like to add two functions to the point3d class, the setX and setY. Both of these functions will be getting one double value each. The setX will just set the value of the chord x field to this parameter value, and similarly the setY function will set the value of the chord y field with this double value. But after that, we would like these setX and setY functions to be returning the object itself. But how am I going to do that? I will be able to do that with saying star this. Okay, that's going to be something interesting. So I'm just going to go up here, and then after these static int get total point count function that we have written previously, I'm just going to say point3d setX, which is going to take a single double field called, let's call it x for the sake of simplicity, And then I'm just gonna say chord x equals x, and I'm just gonna say return this, but not just this, star this. So dereferencing operator followed by the this. As I mentioned, this is keeping the address of that object. So if I call star this, I'm just returning the object itself. So the type of start this is .3d, and the return type of setX is already .3d. So yeah, I am actually returning myself, which might sound a bit strange, but this is what it is. So let me write the setY function in this sense. SetY double y chord y equals chord just y, sorry. So I go down here. Now I'm gonna comment out all of these lines since they are not very useful for this discussion. I will be only keeping the declaration of P1 and the declaration of P2. Afterwards, first of all, I'm just gonna call the calculate distance function of P1 with just giving him P2, and then calculate the distance. Well, and then I would like to do the same thing again, but in between these two calculate distance calls, I just want to change the value of the chord x value of P1 and chord y value of P1 using the chain function call usage. So I'm going to say P1 dot setX 10 dot sety 56 semicolon. Although this seems like a legitimate piece of code, it's not gonna be yielding a very useful result, since I should be putting the returned object of the setY function to P1 itself. Otherwise, that change will not take into effect. So yeah, now the X position has been changed to 10, the Y position has been changed to 56, and the Z stayed the same, and it was like 7 now, so the distance has been increased a lot now. Another way of just using this chain function calls is, well, at the end of set y, I mean, this is an object, right? This is the .3d object now. So the outcome of this part, I can directly call the calculate distance function, because that is also a .3d object. So what I can do is I can simply put it here and then run it again, and then you will see that the result is going to be the same number, 50.4083. So this is another legitimate kind of usage based on the function, chain function call concept using, well, the this keyword. So to summarize, we actually covered a lot of material in this part. So we looked at the class and objects concept in the C++ language. We looked at the global versus local class concept. We looked at the access categories, the public and the private one. We talked about a little bit information hiding. Then we just understand what is a constructor, what is its use, how to write one constructor, how to write multiple constructor using the constructor overloading concept. We also looked at the static keyword, both in the fields and the functions. We also looked at the this keyword, and then we also looked at the how to declare an object using a pointer in C++ language. In the next part, we're going to be looking at the constructors, and we're going to be looking at the templates in C++ language. Thank you for listening. See you in the next part.